We're going to take our lesson on set notation one step further by introducing compound operations. That is, when we take more than one operation. So we learned three basic operations. We learned union, which had the capital U looking symbol. We learned the intersection, or intersect, which had the upside down U. And we learned the complement, which was symbolized with the prime symbol. And I'll just put a capital A. So A prime would mean the complement of A. Like other operations, or parentheses still need to go first. So we still need to obey the rules of order of operations. So if we look at my first problem, it says the complement of A unite B, or a complement of A union B. So we need to first find the complement of A. Remember that the complement means those that are not included in the universal set. My universal set is still the digits 0 through 9, so 0, 1, 2, all the way up to 9. So the complement of A is those numbers that aren't in 9, or aren't in the universal set, excuse me. So if we're looking at my complement of A, it would be 0, 2, 4, 7, 8, 9. Notice that none of those 6 numbers are in my original set A. So remember, complement means the opposite. Now we need to unite it with B. So A prime, or a complement of A union B then. Union means we need to include all of their members and create a larger set. So when we union this with B, we're going to get the result of all of their members. So we're going to add these members to the members I had before. So we're going to get 0, which is repeated in both, 2, which is repeated in both, 4, also in both, 6, that comes from B only, and then we have 7, 8, and 9 that come from the complement of A only. So there's my final set. Notice that my set's quite large. I have 1, 2, 3, 4, 5, 6, 7 members here. And it's just a matter of doing one operation and then the other. If we look at the next one, we have B intersect A and then intersect U. Remember, intersect means the places they overlap. So we care about here, where do those sets overlap? Well, if we look at B and A, we want to know where these two overlap, B and A. We have 0 and 1, those don't. 2 and 3, no. 4 and 5, no. So the only number where they overlap is the 6. So B intersect A is simply 6. Now we need to move outside the parentheses. We need to do 6 intersect U. Well, U, remember, has all the digits. The only place it could possibly intersect is the 6, and in fact it does intersect at that 6. So 6 intersect with U, the only thing that's shared is that 6. The last problem then, let me clean this up a bit, is the complement of A intersect with the complement of B. So we're going to have to do the two parentheses first, and then we're going to have to intersect them. So the complement of A is those things that are not in A that are still in the universal set. So the complement of A is going to be 0, 2, 4, 7, 8, 9. So all those things that are not in A but are in U. And the complement of B is going to be 1, 3, 5, 7, 8, 9. Once again, it's those things that are not inside B but that are still inside the universal set U. And the last thing we need to do is then put them together using the intersect. So intersect, once again, means where are those shared. If we go down our list, 0 is not shared, 1 is not shared, 2 is not shared, 3 is not shared, 4 is not shared, 5 is not shared, there are no 6's, and if you look at the end, we have 7, 8, and 9. Those show up in both locations, so therefore the intersect of A complement and B complement must be the set containing just 7, 8, and 9. Now at this point, it's going to be up to you to practice some of these on your own.